The graph of a quadratic equation is called a parabola. Here we have two examples of quadratic equations, y equal 3x squared, and we'll illustrate here what the graph of that equation results in, which is known as a parabolic shape. Likewise, the second equation is also a quadratic equation, and it's noted here in red what the graph of that equation would look like. Equations of the form y equal ax squared plus bx plus c, which is a quadratic equation with a not equal to 0, have graphs that are either cupped upward or downward. For an upward parabola shown here, the specific equation for this graph is y equal to x squared, and if you note, the leading coefficient is positive 2 with the parabola opening upward. Graphs also, as mentioned, can open downward, and here we have an example. The equation of this parabola is shown here and has a leading coefficient of -3, which results in the parabola opening downward. When the leading coefficient is positive, the parabola will open upward as shown in this example. When the leading coefficient of the quadratic equation is negative, the parabola will open downward as shown in the second example. The graph of a quadratic equation is symmetric with respect to an axis of symmetry as shown here with the dotted line. When folded along its axis of symmetry, the graph has two halves that match exactly. The point at which the equation or parabola crosses its axis of symmetry is called the vertex. On this first graph, we see here is the vertex. It's the point that intersects the axis of symmetry. There is only one point on the axis of symmetry, since this is the line of reflection. Also, the vertex for this particular graph is the minimum or the smallest value for this quadratic equation. For a parabola opening downward, the vertex, which is the point where the graph intersects the axis of symmetry, acts as the maximum for this quadratic equation.